This is our last section, and then we've got a few little things for section 1, and this is 1-9 Lewis structures. So Lewis structures are used to represent the way that multiple atoms come together to make bonds with each other. Okay, so usually, I mean, you can't say that this always works, but there is a set of stepwise instructions that usually is a good way to go about drawing Lewis structures and to get good results, okay? But it takes practice as well. All right, so step 1, write out how many of each element you have and their respective valence electrons. Add an additional electron if there is a negative charge, an overall negative charge on your molecule, and subtract an electron if there's an overall positive charge on your molecule. Now, if you have a 2+ charge, then you would subtract 2 electrons. If you have a 3+ charge, then you would subtract 3 electrons. If you had a -2 charge overall on your molecule, then you would add 2 electrons because each electron counts as a single negative, okay? So, for the central atom, add the most electronegative element. So if you think about it, right, the central atom in a Lewis dot structure is probably going to have quite a few bonds to everybody else surrounding it, and that's why it's the central atom. Well, then let's think about this. If you have an atom that is very electronegative, does that mean that that atom wants to share electrons or wants to take electrons? Well, it means it's greedy for electrons, essentially, and so of course it doesn't want to share electrons. If anything, it wants to steal electrons. So since the central atom is usually the atom with the most bonds, it doesn't make sense to put the most electronegative atom in the center. In fact, the best atom to put in the center would be the least electronegative atom because it's the most likely atom to share with its friends, if you will. So that's why, oh, I just wrote this wrong now that I'm looking at it. Sorry, guys. So sorry. So for the central atom, you usually want to add the least electronegative element to the center. Okay, so I explained it. Even though I wrote the wrong thing, I explained it correctly, right? The least, okay. So for the central atom, add the least electronegative element, which makes sense because typically the central atom makes the most bonds, and therefore you want an atom that's actually going to share the electrons and not be greedy like those super electronegative elements like oxygen. You know, typically that's not a central element because it's so greedy. Okay, number 3, make the skeleton, oh wait, I forgot this part. Lewis, excluding hydrogen, because remember hydrogen only makes one bond, which is kind of nice because hydrogen will only make one bond, which means that hydrogen is going to be a terminal element, okay? Make the skeleton of the Lewis dot structure putting down only a single bond between elements. So you just want to make connections between the elements, okay? And we're going to do practice. In fact, let's start with practice. Let's go through the first 3 here. So, nitrogen with 3 fluorines. First thing we got to do is count how many electrons we have total. So, nitrogen, oh, don't forget to pause and do this on your own first. So, nitrogen has 5 valence electrons. Fluorine has 7, but we have 3 of those little guys. So 7, 14, 21, 22, 23, 24, 6, 26 electrons. Is that correct? Cool. So I've got a math helper over here. So now we're going to put the least electronegative, oh wait, let's make sure we're doing this. And there's no charges, so we don't have to worry about that. Now we're going to put the least electronegative element in the middle, nitrogen, and then we're going to make connections to all of the other atoms that we have. Okay. Okay. So we're going to make the skeleton by putting single bonds between the atoms. And then with the remaining electrons, give them to atoms that are attached to the central atom until they have an octet. So we've got, okay, so we've got 1, 2, 3, 4, 5, 6 electrons so far, okay? So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay. All right, we've got 24 electrons on there so far. And so if the central atom does not have an octet, okay, if you have leftover electrons, give them to the central atom. So we do, we have 2, boom, boom, there's the central atom. And that actually equals 26. So we're done, right? If we had, if the central atom did not have an octet yet, we would form double or triple bonds. And then, of course, for each element now, we need to go in and calculate the formal charge. So if you've done that, then you'll notice that the formal charge for fluorine is 0, for this nitrogen is 0, and then, of course, all the fluorines are the same. So the overall charge is 0. And so this is a valid Lewis dot structure. Okay, let's do carbon dioxide. So carbon has how many valence electrons? 4. Oxygen times 2 is 6, so times 2. 12, 13, 14, 15, 16, so that's 16 electrons total. So what's the least electronegative element? That's carbon, so put carbon in the middle. And then we give everyone single bonds, and then we fill the octets. Well, hold on, let's slow down, I'm going too fast. Now we're going to, how many electrons do we have? 16. So far we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Okay. So we don't have any extra electrons to give the central atom. If the central atom does not have an octet, form double bonds or triple bonds. We'll notice that carbon does not have an octet. So we need to form a double bond. So we're going to take these 2 electrons and we're going to remove them as a lone pair and instead put them, oops, sorry guys, let me try that again. We're going to remove them as a lone, oh no, why is this struggling? As a lone pair, so here they are. We're going to remove them as a lone pair and put them in to form a pi bond between the oxygen and the carbon. Okay, like that. There they are. All right, and then we'll do it again because still the carbon does not have an octet. So we're going to take these electrons that are lone pair on oxygen and move them in as a pi bond to the carbon. And so that's going to mean that we have a pi bond there. And now we can see that carbon does have an octet. Now we can calculate the formal charge for each element or atom here. And so oxygen will be zeros. Both of those oxygens have a 0 formal charge and the carbon has a 0 formal charge. So this is a good Lewis dot structure. Now we can do carbon bonded to oxygen. So carbon is 4 plus 6. For oxygen, that's 6, 7, 8, 9, 10. That's 10, okay. So carbon bonded to oxygen. So that's 2 electrons. So 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10. Now, does everyone have an octet? Well, no. The oxygen doesn't have an octet and carbon doesn't have an octet. So how about we do what we did with our central atoms and we move a lone pair in as a bond. So we're going to take this lone pair, move it in as a pi bond. So now it will look like that. Okay, well still We don't have an octet on the carbon or the oxygen, so let's do it again. Let's take this lone pair on this carbon and move it in as another pi bond. So now, okay, so that actually is 2 pi bonds now. Now, does the carbon have an octet? 1, 2, 3, 4, 5, 6, 7, 8. Yes. Does the oxygen have an octet? 1, 2, 3, 4, 5, 6, 7, 8. Yes, everyone has an octet. Now we need to calculate the formal charges. Oxygen has a positive formal charge, and carbon has a negative formal charge. So there we go. Now let's do water. Well, we all know what water looks like, but let's go through the process. So hydrogen, there's 2 of them. So we've got 2 electrons, and then we have 1 oxygen, so that'll be 6. So 6, 7, 8. 8 electrons we can work with total. Now, if we put the least electronegative atom in the middle, except hydrogen though, because remember, hydrogen is always a terminal atom, that would leave oxygen to be our only option. So we've got 1, 2, 3, 4. So 4 electrons. Now usually we give excess electrons to the atoms bonded to our central atom, but since these are hydrogens, we know that they're only going to have a single bond and no lone pairs. So we will give our last 4 electrons to that oxygen, and we can calculate the formal charges of every one, and they will all be 0. And of course, that's the structure for water.